The journey of the Hubble Space Telescope has been nothing short of revolutionary, marking a significant milestone in space exploration. Launched on April 24, 1990, aboard the Space Shuttle Discovery, Hubble became an indispensable tool for astronomers, profoundly altering our understanding of the universe. Its ability to capture stunning, detailed images opened a new window to the cosmos. However, Hubble's success did not come without challenges. Shortly after deployment, NASA identified a major flaw in the primary mirror, causing blurry, out-of-focus images. This defect cast doubt on the mission's potential. Despite this setback, Hubble continued to operate, capturing valuable images of planets and distant galaxies. The real breakthrough occurred in December 1993, when a team of astronauts was sent on a high-stakes repair mission to correct the mirror's flaw. The mission was a resounding success, dramatically improving image quality. Since then, Hubble has revolutionized our understanding of the universe, unveiling cosmic wonders previously hidden from view, such as the iconic pillars of creation in the Eagle Nebula. These discoveries have expanded scientific knowledge and ignited public fascination with space. Initially designed for a 15-year mission, Hubble has exceeded expectations, operating for over 30 years. Ongoing servicing and upgrades have kept it at the cutting edge of astronomical research, paving the way for future advancements like the James Webb Space Telescope. Throughout its mission, Hubble has captured over 1.5 million observations, contributing to thousands of scientific papers and cementing its place as one of the most productive scientific instruments ever built. In addition to studying planets within our solar system, Hubble has provided groundbreaking insights into galaxies billions of light-years away, fundamentally transforming humanity's view of the cosmos. One particularly fascinating discovery involves a celestial structure that resembles a human hand, known as the Hand of God, captured by NASA's Nuclear Spectroscopic Telescope array. This pulsar-wind nebula, formed from a supernova, has at its core a rapidly spinning pulsar named PSR B059-58. The powerful stream of particles emitted by the pulsar interacts with magnetic fields, creating the hand-like appearance. While this formation may appear as a hand, it is an example of pareidolia, a psychological phenomenon where people see familiar shapes in random patterns. The Chandra X-ray Observatory previously observed the structure at lower energy levels, and combining data from both Chandra and NuStar has deepened our understanding of pulsar behavior. This discovery, along with others, sheds light on star life cycles and the aftermath of supernovae. Mars, often called the Red Planet, has long fascinated scientists and space enthusiasts. Recent studies suggest that Mars once had a much more hospitable environment potentially capable of supporting life. The planet's southern highlands, especially near Hellas Basin and Hesperia, show networks of valleys resembling river systems on Earth. These formations suggest the presence of flowing water around 3.5 to 4 billion years ago. Geological evidence indicates that Mars once had a much thicker atmosphere, allowing for the presence of liquid water on its surface. This discovery is particularly exciting for astrobiologists, as water is essential for life as we know it. While the current Martian surface is inhospitable, with its thin atmosphere and cold temperatures, the planet's ancient conditions may have been conducive to microbial life. Various factors, including groundwater and melting glaciers, likely contributed to the formation of Mars's ancient water systems. To explore Mars's potential for past or present life, space agencies are planning future missions. The ExoMars mission, a collaboration between the European Space Agency and Roscosmos, aims to send a rover to Mars to search for signs of life beneath its surface. This mission will be complemented by the ExoMars Trace Gas Orbiter, which will study the Martian atmosphere from above. These missions are part of a broader strategy to explore Mars comprehensively, with future plans potentially involving the return of Martian samples to Earth for detailed analysis. Such a feat would significantly advance our understanding of the planet's history and potential for life. Studying Mars's watery past is not just about understanding one planet. It provides valuable insights into planetary evolution and the conditions necessary for life to emerge and thrive. By comparing Mars's history with Earth's, scientists can better understand the factors that make a planet habitable and how these conditions change over time. Recently, NASA scientists made a groundbreaking discovery on Uranus, observing a polar cyclone at its north pole for the first time. This finding adds Uranus to the list of planets in our solar system with such atmospheric features, advancing our knowledge of planetary weather patterns. The cyclone, characterized by a warm, dry core, was detected through the analysis of radio waves emitted by the planet, which are not visible through traditional optical observations. Unlike Earth's hurricanes, which move across oceans, this cyclone remains stationary at Uranus's pole. The planet's tilted axis causes extreme seasonal changes, making the observation of its poles particularly interesting to scientists. Observations from the Very Large Array in New Mexico, made between 2015 and 2022, revealed that Uranus's north pole was warmer and drier than expected, suggesting the presence of a large cyclone. This discovery challenges previous assumptions about Uranus's atmosphere and highlights the dynamic nature of gas giants. Comparisons to similar features observed on Saturn during NASA's Cassini mission offer valuable insights into the behavior of storms across different planets. One of the most intriguing aspects of the cyclone is its stability, as it appears to be a long-lasting feature, unlike hurricanes on Earth that fade after landfall. The timing of this discovery is particularly fortunate, as Uranus's current orbital position allows telescopes to clearly observe its poles, providing scientists with a rare opportunity to study them in detail. This new data enhances our understanding of planetary science and opens new avenues for future research. Further studies may focus on the cyclone's internal structure, its interaction with Uranus's magnetic field, and its role in atmospheric circulation. As technology and observational techniques improve, we can expect more discoveries that not only enhance our knowledge of distant worlds, but also provide insights into the diversity and complexity of planetary systems. Additionally, the discovery of quasi-periodic pulsations, QPPs, resembling heartbeats during solar flares has revolutionized our understanding of solar storms. These signals, first detected in 2022, could hold the key to decoding the sun's mysterious heartbeat and provide critical insights into solar activity and its impacts on space weather. Analyzing data from a medium C-class solar flare on July 13, 2017, a research team discovered two distinct pulsation patterns. The primary pulse, occurring every 10 to 20 seconds, was traced to the base of the current sheet where magnetic field lines break and reconnect during a solar flare. A secondary, softer pulse with a 30 to 60-second interval was observed across the entire current sheet. This finding challenges existing theories on solar flare dynamics and energy release mechanisms. The researchers suggest that both pulse patterns likely arise from the formation of magnetic islands within the current sheet, where magnetic field lines twist and reconnect, playing a crucial role in energy release during solar flares. Understanding these pulsations is essential for predicting and mitigating the effects of solar storms on Earth. Solar flares and coronal mass ejections, CMEs, can disrupt satellite communications, affect power grids, and pose risks to astronauts. By decoding the sun's heartbeat, scientists may develop better early warning systems for such events. The research team's findings also open up new avenues for studying the sun's magnetic behavior. Analyzing these pulses can provide insights into the complex processes occurring in the sun's atmosphere during flares, which are difficult to observe due to the intense heat and radiation. Moreover, this discovery may have implications for understanding other stars. If similar pulsations are detected in distant stars, it could offer valuable information about their flare activity and magnetic properties. The study of quasi-periodic pulsations emphasizes the importance of long-term solar observation programs, as detecting and analyzing these subtle signals requires continuous, high-resolution monitoring of the sun across various wavelengths. As solar activity intensifies toward the peak of the current solar cycle, anticipated around 2025, these insights will be vital for predicting and understanding solar weather events. The sun's cosmic pulses provide crucial clues to unraveling the mysteries of its behavior and its effects on our technological society. This galaxy, known as M87, has expanded over time by absorbing smaller galaxies, which may explain its vast size and large number of globular clusters. Originally discovered by Charles Messier in 1781, M87 remains a focus of ongoing research. With an apparent magnitude of 9.6, it can be seen with a small telescope under favorable conditions, especially in May when viewing is ideal. Recent Hubble Space Telescope observations have captured stunning visible and infrared images, showcasing M87's elliptical form and the striking jet extending from its core. These new details offer astronomers valuable insights into the structure and behavior of this massive galaxy. Studying M87 is essential for understanding how large galaxies form and evolve, how supermassive black holes behave, and how galaxy clusters operate. As observational tools and techniques improve, M87 will continue to reveal new mysteries about the universe and the extreme environment within it. NASA's Curiosity rover, launched in 2011, has been exploring Mars's Gale crater since 2012, providing invaluable insights into the red planet's past. Under the leadership of project scientist Ashwin Vasavada, the mission is focused on unraveling the mysteries of this particular Martian region. Gale crater, formed about 3.5 billion years ago, offers a unique window into Mars's geological history. The primary question driving Curiosity's mission is whether this area could have supported microbial life in the distant past. During this period, Mars likely had a much thicker atmosphere and abundant liquid water, creating conditions potentially favorable for life. Curiosity's mission goes beyond searching for actual life forms and aims to identify the basic requirements that would have made life possible. These include the presence of liquid water, carbon, and other essential chemical elements, as well as potential energy sources that primitive microorganisms could have utilized. In its inaugural year, the Curiosity rover made a groundbreaking discovery at Yellowknife Bay, unveiling signs of an ancient lake bed, which offered vital insights into Mars's historical environment. Chemical analyses revealed that the area was neither overly acidic nor excessively salty, indicating it may have been habitable for microbial life. Further studies identified essential life-supporting elements like carbon, nitrogen, sulfur, and phosphorus. Moreover, Curiosity detected potential energy sources that could have fueled microbial metabolism. These discoveries collectively imply that ancient Mars, particularly within the Gale crater region, may have had conditions conducive to supporting early life forms. The rover's capacity to analyze the chemical composition of Martian rocks and soil has been instrumental in unraveling the planet's environmental history. Kepler 186f, identified by NASA's Kepler Space Telescope, was the first Earth-sized exoplanet found within the habitable zone of its star, situated approximately 500 light-years away in the Cygnus constellation. Kepler 186f orbits an M-dwarf star. The discovery of Kepler 186f marks a significant step in the search for potentially life-supporting planets beyond our solar system, as it resides in the star's habitable zone where liquid water may exist. Though its composition and mass are uncertain, it is likely rocky, raising hopes for finding more Earth-like planets. Titan, Saturn's largest moon, has a unique hydrological cycle with lakes and seas of liquid methane and ethane. NASA's Cassini mission revealed that Titan's lakes differ in composition across its hemispheres and may have formed similarly to Earth's large lakes. These lakes experience seasonal fluctuations, indicating a methane-ethane cycle akin to Earth's water cycle. While Titan's lakes cannot support life as we know it, their complex organic chemistry presents possibilities for alternative life forms. Upcoming missions like NASA's Dragonfly in 2026 will explore Titan further, potentially shedding light on planetary environments and Earth's early conditions for life. As the exploration of our solar system continues, the scientific community is also keenly interested in the outer planets, particularly Jupiter and Saturn. These gas giants offer unique insights into planetary formation and atmospheric dynamics. For instance, Jupiter's Great Red Spot, a massive storm that has been raging for over 350 years, serves as a prime example of the complex weather systems that can develop in such dense atmospheres. Recent observations from the Juno spacecraft have revealed detailed information about this storm's structure and the powerful winds surrounding it, enhancing our understanding of atmospheric phenomena not only on Jupiter but also on exoplanets with similar characteristics. Saturn, renowned for its stunning ring system, is another focal point of interest. The Cassini-Huygens mission, which ended in 2017, provided a wealth of data about the planet's moons, including Titan and Enceladus, Titan's thick atmosphere and liquid methane lakes present an environment that could potentially harbor life forms with biochemistry vastly different from what we know. Enceladus, on the other hand, has shown geysers that spew water vapor and organic compounds, suggesting that a subsurface ocean exists beneath its icy crust. These discoveries make both moons prime targets for future missions aimed at understanding the potential for life beyond Earth. The search for extraterrestrial intelligence, SETI, has also gained momentum in recent years. Various initiatives focus on detecting signals from distant civilizations, using advanced radio telescopes and algorithms to analyze vast amounts of data. The discovery of potentially habitable exoplanets has heightened interest in these searches.